Hey everybody, so we are going to be applying the parallelogram theorem and their converses and whatnot to go ahead and find the missing values and the variables of these different examples. So we're going to start off with example 1 and we're going to find the unknown variables in the parallelograms below. So this one is going to be using the theorem that states that opposite sides are congruent. So that means 18 is congruent to 3x over here, which means we're going to set it up so we can solve for x, and you get x is equal to 6. Okay, not bad. The reverse, or I'm sorry, the same holds for the opposite set here. 22 is equal to y minus 5, which means you're going to add 5 to both sides, and you get 27 is equal to y. And so now you've got it. All right, so this next one is a little bit harder. You're going to have to do a little bit more work. All right, we've got 28 and 9y plus 1. And we've also got 11 and 2x minus 5. So we've got 2x minus 5 is equal to 11. So add the 5 and you get 2x is equal to 16, which means x is going to equal 8. All right, and we have 9y plus 1 is equal to 28. Again, this is using that opposite, both pairs of opposite sides are congruent. Right, and we got 9y is equal to 27, and y is equal to 3. All right, so it's really that easy. All right, now that's applying one of the 5 theorems that we're using. Let's do this next one. This says that the opposite sets of angles are going to be congruent, and that's which theorem we're going to be using there. All right, so we're going to find the unknown variables in the parallelograms by noting that these two are congruent, as are both of these. So we get 139 is equal to 7x minus 1. Well, that's pretty easy. We could take it from there. Add 1 to both sides. We get 140 is equal to 7x. And so x is going to equal 20. All right, same thing. And this time, we've got variables on both sides, and that's okay. We can handle it. All right, so I'm going to move my lighter variable just so I'm not working with negatives as much. Add the 10 over, and I get 9 equals x, or x equals 9. Either way, they are both correct. All right. Let's do this next one. This is going to be using the theorem that says that consecutive angles are supplementary. I don't believe we wrote down both on this. There we go. All right, so consecutive angles are supplementary, which means that 9x plus 135 is going to end up equaling 180. So we subtract the 135 from both sides, and you're going to get 9x is equal to 45, which means x is going to equal 5. Oof. So this one's a little bit different. We've got both an x and a y working out. So one way we could set it up would be this. We know that these two are congruent, but both of these are supplementary, as are both of these. They're consecutive angles, which means they're supplementary, right? So we're going to, I'm going to do the first one. I'm going to do 5x plus 20 plus 120 is equal to 180. So I get 5x plus 140 is equal to 180. 5x is equal to 40, and x is equal to 8. Well, that's awesome. Now, there are two ways you can do this. You can take this 8 right here, drop it in, and figure out that this angle is 60 degrees, and then set this equal to 60 and solve for y. Or what you can do is you can also set this up as a supplementary and make it be 8y plus 4 plus 120 is going to equal 180. Either way, you're going to end up getting the same answer. As you guys have all heard me say, work smarter, not harder. So you've already done the legwork for finding x. So let's drop it in. 5 times x, which was 8, plus 20 is going to equal that 8y plus 4. All right, sorry about that. So now we've got 40 plus 20 is going to equal 8y plus 4. 60 is equal to 8y plus 4. You get 56 is equal to 8y, which means y is going to equal 7. So even if you've got two variables, you can still figure out. You just have to decide how you want to move forward. All right, in our last set of examples, these are going to be using the theorem that the diagonals are bisecting each other. And that means that 5x minus 1 is going to be congruent with the 14, and the 18 is congruent with the 9y. So we can set it up as 14 is equal to 5x minus 1 to solve for x, and 18 is equal to 9y to solve for y. You can already tell that y is going to be 2 because, well, we know our multiplication table, hopefully. And then the other one, all we're going to do is add the 1 to both sides, and we get 15 is equal to 5x, meaning x is equal to 3 in this case. All right, this next one, some of you see it and you're just like, I don't like it anymore. Miss Obji, make it stop. But it's okay. Remember, the diagonals are bisecting each other. What that means is, right here, if they're bisecting at that point, these two are congruent and these two are congruent. That diagonal is split into two equal parts. So we can get 5x minus 8 is equal to 4x plus 4. But you can also get 7y plus 2 is equal to 10y minus 7. And you could solve for both x and y by setting up your equation from here. All right, so I've gone ahead and moved it over, and I got x minus 8 is equal to 4, and so x is equal to 12. For this one, I moved my lighter variable over, and I got 2 is equal to 3y minus 7. Add the 7 to both sides, you get 9 is equal to 3y. So y is equal to 3. And that's it. All right, so you were able to apply the four of the 5 theorems to solve for many missing variables. Sometimes you'll have to set up a system of equations, but you know how to solve. And if not, check the videos at the end of this. You'll get some help. All right, there is one more theorem, however, that we need to go over. And that is the parallel lines and multiple transversal theorem. So this one states, if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Right? And I do have this on the back of these examples, and we're going to tape it in. I want you to go ahead and label this up. And I'm going to go this way. A, B, C, D, E, F. Same thing here. And the reason why I'm doing that is because I'm going to have my if statement here, and then on the other side, my conclusion on the other side. So if AB is parallel with CD, and these are parallel with EF. So AB, CD, and EF are parallel. All right, and I'm going to mark it up on both because it's going to stay the same. And notice it has to have this as well. AC is congruent to CE. Then, what this theorem states is that the opposite sides right here, these two, BD and DF, will also be congruent, because they will be congruent segments on every transversal, including the other one, because the parallel lines are split up equidistant. All right, so let's try this example right here. And the first thing we're going to do is we are going to mark it up. All right, so if AE is parallel with BF, is parallel with CG, and is parallel with DH. Okay, so we've marked up our parallels. Then, and here's that next part, AB is congruent to BC is congruent to CD, which is equal to 2. So the way that I would mark that up is I would do AB, BC, CD, and I would mark this one up as 2. We know that BC and AB are also 2 then. And then lastly, it also states that EF right here is 2.25. This one right here is 2.25. And we are being asked to find what is EH. So we're looking, let me move this, for this entire segment. Well, guess what? Using this theorem that we've just talked about, the parallel lines and multiple transversals theorem, you know that because each of these lines are parallel and it's intersecting a set of congruent segments, these are also congruent. Which means if EF is 2.25, so is FG, and so is GH. Or another way of doing that is that each of these three can be multiplied, right? And we can get 2.25 times 3 to get what EH is, and you end up getting 6.75. All right, that's all I got for you. Thanks for watching.